A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we will be talking about a very advanced software in research, especially used for structural equation modeling, that is SmartPLS. So, how to use this magnificent software which has certain features which are not available in AMOS. So first let us look into what is structural equation modeling. Structural equation modeling or SEM is a statistical method which enables the researchers to evaluate theoretical models using both observable and latent variables and thereby look into the intricate causal links. Users with different degrees of statistical knowledge can use SmartPLS because of its user-friendly graphical interface, which makes it simple to develop and analyze structural equation modeling. What are the special features or advantages of SmartPLS, or why you should prefer SmartPLS over AMOS? It is a sophisticated and accessible software suite that assists scholars and analysts in the realm of SCM, does not assume normality of the data, which is the primary consideration when we do the analysis through AMOS. The maximum likelihood estimation method in AMOS assumes that your data exhibits normality and then only you can move forward. So normality is not the fixed assumption to conduct a SEM in SmartPLS. It can work with smaller sample sizes. This is again a boon for those who find it difficult to conduct analysis because their sample size was not adequate. So here in SmartPLS, though it requires calculation, we will be discussing in future videos how to assess or calculate the sample size required for different models to be analyzed in SmartPLS. For now, we just see it as it requires a smaller sample size than AMOS to work well. It can work well with both reflective and formative measurement models. You can go back to the playlist and watch my video on the difference between reflective and formative indicators or reflective and formative measurement models. So wherein the indicators of the latent variable are the effect of that indicator. We call them effect indicators or reflective indicators. In a case where the latent variable is formed by the observed indicators and all of them have different meanings, in that case we call them formative indicators of the latent variable. So AMOS can only work with reflective kind of measurement models, but SmartPLS has an advantage over AMOS in that it can work with both reflective and formative measurement models. Adaptability in capturing the multifaceted essence of constructs. It can work well and quite conveniently with first order and second order models. We are going to discuss all of them in the subsequent videos. What is a first order model? What is a second order model? So we'll be seeing them along with practical examples. It can also examine mediation and moderation effects, thereby facilitating a deeper exploration of the underlying mechanisms and contingent relationships between the variables. MGA, or it is better known as PLS MGA, enables the users to juxtapose and differentiate results based on categorical variables such as gender or age groups. So we can very easily conduct MGA in SmartPLS. It comprises of robust tools for assessing the model fit, estimating the path coefficients, and generating comprehensive reports. Now, I'll take you to SmartPLS. Before going to the software, these are some of the useful resources. One is Ringel, Wenje and Becker, who are the developers of SmartPLS 4. We must acknowledge them and thank them for developing this beautiful software. The second paper which I have mentioned over here is Partial Least Square Structural Equation Modeling using SmartPLS, a software review. So again, you can look into this paper to find out more about SmartPLS. So here we are in our SmartPLS interface, and I'll show you right from the beginning. SmartPLS can accept input as a .csv file. So first we need to click on new project. I name this project as behavioral intention like this and click OK. After naming this new project as behavioral intention, the next step is to import the data. Now we must take care that SmartPLS accepts data in .csv format and not in .xls format. For that purpose, I need to convert my data. In case you see here, this is in Excel format. This is my data set. FQ denotes food quality, CA is cultural authenticity, SQ is service quality, VM is value for money, BI is behavioral intention. So all these latent variables have been measured by 4 indicators, and all these indicators are measured on Likert 5-point scale. So that is all about my data. It's the data of 204 respondents. You can see here case ID, it goes up till 204. So here it is 204. So I have this data, this sample data, and we'll be analyzing it through SmartPLS. I'll be telling you how to import and use this data to build up your measurement model in SmartPLS. Now, you need to change this Excel data into .csv. How you can do that? You go to File, go to Export, and now you go to Change File Type and CSV, Save As, and save it on your desktop. Save. So now I have converted this data to .csv format so that I can import it in my SmartPLS. Now I'll click on double click to import data, and I'll go to my desktop, behavioral intention, comma separated value file, CSV file, right, which we created right now. I click on that file and click on open, and now click on OK, and you see how well and how quickly SmartPLS has grabbed all the information from my data sheet. So I have here the missing values, mean, median, minimum, maximum, and I have the standard deviation, excess kurtosis, and skewness. So all the descriptive statistics of my data are presented here automatically, which we needed to go into a certain option of descriptives to find out if we are using SPSS. But in SmartPLS, we get them directly. Now, how to build your model? Double click it, and now I can build my model. How to build my model? You see here all the indicators are displayed over here. So what will I do? I'll click on FQ1 and then I'll press shift and click on FQ4. Now I've selected all of them. Drag them over here like this. You see how easily I found the latent variable on food quality. Now I'll do the same for CA1. Click on CA1, press shift button. Now click on CA4 and drag it like this. Easy? Right. So again for SQ1 to SQ4, I click and drag it. VM1 to VM4, click and drag it. VI1 to VI4. So I click and drag it. Now I have all my latent variables in this data sheet. What next? I can easily make it a bigger canvas like this so that my model is presented well. Now I name the latent variables. So right click and go to rename. Now this is food quality, and this is Cultural authenticity. Remember that there shouldn't be any spacing when you name the latent variables. Otherwise, the software will not accept that name. Third one is service quality. This one is behavioral intention. So I'm just naming them like this. And the last one is value for money. Without any spacing, I'm doing it like this. So now I have all of them. Now, what needs to be done now? So, as in Amos, we had to build a separate measurement model and a separate structural model. The advantage with SmartPLS over here is that we just need to make one model, and out of that we can do the measurement model assessment as well as we can do the structural model assessment through one model itself. Now, how to do that? First, I need to shift them to make some space over here. How to shift them? I click on select. So I selected this one. So how to shift this entire thing? Like this, we can easily shift. See, in case I want to rotate their indicators, shift the indicators to the left or right, align indicators left or right, I can do like this. See, align indicators right, align indicators right. I can easily move them, right? And just by clicking on them, I can shift all of them. So in this case, the model which I'm trying to assess is, now these four latent variables are my independent variables or my exogenous variables, and behavioral intention is my endogenous or dependent variable. Now, how to connect them? So once I made it beautiful like this, aligned them, made them a little symmetrical, now I will connect them. So go to connect and connect them like this. So you just drag it and drop it on the dependent variable like this. So now you see all have turned blue instead of red. That means your model is ready to be executed. That's why it has automatically turned blue in color. Now what I need to do? Now my model is ready. The data has been fed into this model. This model says that there are four independent variables and one dependent variable. It's a case of multiple linear regression. So I can do that. I go to calculate, and herein I have options like PLS algorithm and bootstrapping. Now in this case, what I need to do first is I do PLS algorithm, and in this I keep the defaults as path, maximum iterations 300, stop criterion 10 raised to power minus 7. That is quite okay. In case you need information on what is maximum iterations, what is the weighting scheme, so you can read this thing and you'll get an idea of that. So this is quite okay for now. We click on factor in case we are doing a factor analysis. So here we are assessing the path relationships. So let us click on start calculation. How quickly it has shown us the path coefficients in a matrix form and in a graphical form, a bar graph form, right? So we can check it out in the matrix form. So you see it's the path coefficients, behavioral intention, cultural authenticity, food quality, service quality, and value for money. BI is my dependent variable, and the path coefficients it exhibits with other four independent variables is shown over here, right? So the maximum strength of the path coefficient is depicted with service quality being 0.370. The lowest is with value for money 0.069. So this was the path coefficients. Now I can see them in my model itself. You see here, these are the path coefficients. This is R square. So once you hover over it, you'll get the R square, which is coefficient of determination, or you can say regression coefficient, R square. 38.4% of variance in the behavioral intention is computed by these four independent variables, is attributed by these four independent variables. Now, what are these? These are factor loadings. All of these are factor loadings, and all of them are reflective indicators, because you can see the arrowhead is going from the latent variable to the observed indicator. And now if I want some more information, I can go to check, you see, outer loadings. So these are the outer loadings you see over here. So all these outer loadings have to be greater than 0.7. In case they are lesser than 0.7, then SmartPLS will automatically highlight it in red so that you can take action towards it. Now, for FQ4, it is 0.692, which can be rounded up to 0.7. So I don't think there's a need to remove this indicator. We can keep it and go ahead. If it is quite less than 0.7, say it's 0.6 or 0.5, then we might think to remove that indicator from our model to get a better model fit, which will of course give better results. So we can check out the same thing in the model. You see, all of these are factor loadings. In case this is a formative indicator, then in that case we call them outer weights. In that we check the outer weights, but in reflective we check the factor loadings. So what else can we see over here? You see outer weights. So there's no point in checking outer weights over here because it's a reflective model. Now I can check discriminant validity, construct reliability. You see here, construct reliability, Cronbach's alpha, composite reliability, all composite reliability above 0.7, Cronbach alpha above 0.7, quite good. That's why it's in green. Average variance extracted, a measure of convergent validity, is all above 0.7. So you see it has to be above 0.5. So there it's all above 0.5, quite good, right? And then I check discriminant validity. So again, in discriminant validity, they have to be less than 0.85 if we go with HTMT criteria. So I clicked on heterotrait monotrait ratio criteria and I get all these ratios below 0.85. So that means my model is quite okay. So we check the construct reliability and validity, we check the discriminant validity, and we can check the collinearity statistics as well. So here you have the outer VIF values. You see, this is done to check the multicollinearity issues. So in case you find values over 5, here none of the values are above 5, it is 3.722, it is 3.5. So in that case, you can say that you do not have any multicollinearity issues because your VIF values are lesser than 5. We have checked the measurement model and now we can check the structural relationships. For checking the structural relationships, we will have to go to the bootstrap option over here, which is this bootstrapping, and do the bootstrapping. I'll discuss how to do bootstrapping in the next video. So I hope you enjoyed this video and you learned a lot about how to use SmartPLS. We'll of course be talking about how to do the structural model assessment through bootstrapping procedure in SmartPLS in the upcoming videos. Thanks for now. Keep learning and keep watching for more.